Hello and welcome. I'm Megan Van Emmen, Extension Beef Cattle Specialist with Montana State University. And today for our Montana Beef Cattle Producers program, we are going to be discussing the beef digestive anatomy and nutrition basics. This grant for this program was funded by the Western Extension Risk Management and Education program through USDA funds. So when we're looking at meeting requirements for our beef cattle, our nutrient requirements are based on not only the requirements of the cow, but also on the bacterial population within the rumen. There are 6 classes of nutrients we need to consider: water, protein, carbohydrates, fat, vitamins, and minerals. And we'll get into digestion of a couple of those here later in the presentation. Now, one thing to keep in mind, our carbohydrates and fat are also known as our energy sources. And to maintain rumen and animal health, we need to meet all of these requirements. There are 4 compartments to the ruminant's stomach. So they have one stomach, 4 different compartments. The first is the reticulum, also known for its honeycomb structure. We have the rumen, which is the big fermentation vat or paunch. The omasum, which is known for its mini plies, like leaves of paper for a book, and the abomasum, which is also known as the true stomach. One thing to keep in mind for those calves that are pre-ruminants, calves are born with a much larger abomasal capacity than rumen capacity because that rumen has yet to be established. And it's important to note that milk bypasses the reticulum and rumen due to the esophageal groove and enters the abomasum directly. So while calves are on a strictly milk diet, that rumen will not develop to create that big fermentation vat that we normally see in our adult ruminants. Once that calf begins to consume feedstuffs other than milk, such as forages and grains that they might begin to graze out on the pasture, that rumen starts to develop a microbial environment because the esophageal groove does not shut to bypass the reticulorumen. So as that calf grazes, the rumen starts to grow and proliferate, and that abomasum begins to shrink because less of the feed is coming from the milk, and we're starting to get a much greater growth in the rumen, and that microbial population is developing. So as you see in this picture here at the bottom, this is the pre-ruminant. The abomasum is much larger. The rumen is much smaller. The reticulum is quite a bit bigger as well. And then the omasum actually remains fairly constant in size in proportion to the other compartments. So when we're thinking about pre-ruminants, the abomasum is its main functioning compartment during the time of milk consumption. The rumen has yet to establish its bacterial and microbial populations. The rumen is much smaller in proportion to the other 3 compartments compared with the abomasum in a pre-ruminant. What is occurring is that milk is bypassing the reticulorumen compartments to enter the abomasum directly due to the esophageal groove, which shuts when those pre-ruminants are nursing. Now, as that calf begins to consume other feedstuffs, such as grain and forages, the microbial population will begin to develop in the rumen, and the rumen will begin to grow and proliferate, and the papillae within the rumen will begin to increase in size and begin to digest nutrients, thus increasing the size of the rumen. Now, as we look at the picture in the bottom right, this is a functional ruminant. The rumen has increased in size due to that microbial development and the proliferation of those papillae. The abomasum has shrunk in size. We still have a functional abomasum and is still known as the true stomach with low pH. However, the rumen is now our main area of digestion compared to a pre-ruminant. Now, as I stated previously, the reticulum is known for its honeycomb structure, which we can see in this picture here. You can see these little honeycomb structures here, the octagons, and the reticulum's job is to trap those large particles or then bring those large particles up, or regurgitate them, known as chewing their cud, to further break those large particles down by chewing again, and then that animal will re-swallow and those will re-enter the rumen. So as those larger particles get trapped, they're regurgitated, they chew their cud, they're re-swallowed, and that's the reticulum's main job, is to trap those large particles and allow for better digestion through the regurgitation and chewing, and then back into the rumen. It just allows those microbial populations to better attach and create those smaller particles for better digestion. Now for our rumen here, our fermentation vat, it is quite large. It can fill a 50-gallon drum with its contents of both solid and liquid contents. So as we can look at this picture here, you can see this little fuzzy carpet area. Those are the papillae that increase the surface area of the rumen and allow for better nutrient absorption and greater contact with the rumen wall than just a smooth surface. So they can do a much more efficient job at absorbing those nutrients. Now, the contents or the microbial population in the rumen contains bacteria, protozoa, and fungi, and those all aid in digestion. So if we look at our microbial populations for bacteria, in 1 milliliter of rumen fluid, you can find upwards of 25 billion bacteria, 10 million protozoa, and 10,000 fungi. So the populations of those are very large, but they also aid in the digestion of all of our feed materials, and they allow for our ruminants to be able to digest forages and fibers in a way that non-ruminants cannot. They are responsible for the fiber portion of digestion, also cellulose and hemicellulose. They also are involved in the formation of B vitamins within the rumen, and then digestion of proteins. And also, microbial crude protein can make up a large proportion of the protein absorbed in the small intestine by a ruminant. Now, with the rumen being the large fermentation vat that it is also the major heat source for animals during the winter months. And cattle can spend upwards of 50% of their day ruminating or digesting those feedstuffs that they have consumed. And this mainly occurs on those forage-based diets, as they are more slowly digested than our grain-based diets. So what's occurring within the rumen is called peristalsis, or the turning of the rumen. And this is occurring because we have 3 distinct levels within the rumen. At the top is your gas area, in the middle is your fibrous mat, and then in the bottom is your liquid portion. So to ensure that the contents of the rumen are always mixed and moving those microbes so they can attach to the feedstuffs and aid in digestion, that rumen is constantly being turned over. So we're going to watch a video here to watch this peristalsis occurring. So as you can see, we've emptied most of these contents out. You can just see the fibrous material from the hay that they are consuming still in the rumen. But as you can see, these grooves begin to rotate and move, and she will then turn those contents over as needed, usually about once every minute or two, to constantly move this liquid portion into contact with those rumen contents. So this allows for better digestion of those fibrous feedstuffs, such as low-quality forages, that we can a lot of times see in our fall and winter months. Now, the rumen also digests energy, such as the carbohydrates and fats. So if we think in terms of energy digestion, we get the main as carbohydrates. You can also digest fat for digestion. However, the majority of the feedstuffs are carbohydrates, where the microbial population breaks down the cell walls of those fibrous materials into carbohydrates and then into volatile fatty acids, the main three being acetic, propionic, and butyric. These all serve as cellular energy sources. So when we look at our forage-based diets or most of our grazing animals, the majority of their volatile fatty acid that's going to be produced is acetic, whereas in a grain diet, the propionic increases in amounts and actually becomes more of a 1-to-1 ratio of acetic and propionic, with butyric always being the third most concentrated within the rumen. Now, within that rumen, fiber and starch are mostly digested. There are always undigestible portions that just don't get broken down as efficiently as other simple sugars and things like that, whereas if you have a sugar source that enters the rumen, that is primarily all digested quite rapidly with those microbes. Now, if we look at protein digestion, we can have different formations of protein. So we have the crude protein in the ration, but it can be either be like a natural protein, such as a soybean meal or dry distillers grains, or a non-protein nitrogen, where it is strictly a nitrogen source that enters the rumen and is 100% rumen degradable. Now, when these enter the rumen, the natural protein is broken down into an escape protein or a rumen undegradable protein into the small intestine, or we have our rumen degradable protein or our non-protein nitrogen, which is then digested by the rumen bacteria, forming ammonia, which is a nitrogen source, and that ammonia can be absorbed through the rumen wall and enter the bloodstream to be traveled to the liver, or we can get nitrogen then that is absorbed back into the saliva, which then re-enters the rumen to be broken down again into ammonia. Now, the excess nitrogen from the liver will then be excreted in the urine. Now, the ammonia is an excellent energy source for our bacterial population, and this ammonia is used by the bacteria and can form a fermentable energy. Now, our bacterial population can also form what's called microbial crude protein, which can also serve as a pretty large protein source for our animals as it enters the small intestine. Now, that rumen bypass protein or rumen undegradable protein and that microbial crude protein can enter the small intestine and then be absorbed as protein sources or amino acids that for use of nitrogen retention within a ruminant. Those amino acids are absorbed into the blood, where the remaining, those that are completely unabsorbed or undigested, will be excreted in the feces. And one thing to keep in mind, not all protein will be degraded. Even a portion of your rumen undegradable protein will be excreted within the feces. For example, such as like a distiller's grains, if those grains were heated too rapidly or at too high of a temperature or for too long, you can permanently denature the protein and not allow it to be absorbed within the rumen, which means that it is not going to be used as a nitrogen source. So just keep that in mind. If you're feeding those rumen undegradable sources, you still need to provide a rumen degradable protein source for the rumen bacterial populations. Now, once the feedstuffs are digested within the rumen, they travel to the Omasum, or the many folds, and as you can see, it looks like leaflets in a book. And its main function is to remove water from the contents as they move on into the abomasum. Now, if we look here again, we have the abomasum, which is also known as the true stomach. It has a very low pH, between 2 and 3. So its main purpose is to break down proteins into those of individual amino acids to travel into the small intestine for absorption. Once entering the small and large intestines, the small intestine has 3 individual segments: the duodenum, jejunum, and ileum. And its main function is to absorb those nutrients that were previously broken down in the abomasum, those proteins and individual amino acids. The small intestine also increases the pH back up into that 6 or 7 range versus the abomasum, which was in that 2 to 3 pH range. And this is done through the mixing of secretions from the pancreas and the gallbladder that not only aid in the increase in pH, but also in the nutrient breakdown and absorption. The main function of the large intestine is to absorb water, which is mainly accomplished in the colon. Now, the cecum doesn't have a large role in ruminants, such as like a horse, which is known as a hindgut fermenter, where there is quite a bit of nutrient absorption within that cecum. The main portion of the large intestine that is absorbing that water is the colon. The cecum does not have a large role in our ruminants. With that, that is a brief nutrient breakdown basics and digestive anatomy of our ruminants.